numbers by fractions. Make sure you have these notes downloaded into GoodNotes so that you can follow along. Also make sure you have your Virtual Manipulatives app ready to go, which we'll be using a lot during this lesson. Okay, let's go ahead and get started. Okay, so we all know that math can be like its own language. So the first thing we need to do is learn a new vocabulary word, or in other words, speak math. That vocabulary word is called reciprocal. Make sure you get it spelled correctly, reciprocal. A reciprocal is any two numbers with a product of 1. And I'll show you an example in a minute here. So any two numbers with a product of 1. And remember, product means multiplication. Okay? To help me remember reciprocal, I like to think of the word refliprical. Make sure you write that down. Reciprocal, refliprical. It's kind of fun to say. And the reason why I call reciprocal a refliprical is because what you're doing is flipping what is on the top and the bottom. So for example, if I gave you the fraction 4/5 and asked you to find the reciprocal or refliprical, you would flip what's on the top and the bottom. So the 5 would be on the top and the 4 would be on the bottom. So we've simply traded what's on the top and what's on the bottom. And that's its reciprocal. Let's try a few more examples together. Let's say I gave you the fraction 2/3. The reciprocal or refliprical of 2/3 is 3/2. And just to double check, let's multiply them together. 2/3 times 3/2. Remember, you learned from multiplying. Multiply the numerators together, multiply the denominators together. 2 times 3 is 6. 3 times 2 is also 6, and 6 divided by 6 simplifies to 1. So we can see that these numbers really are reciprocals of each other because their product is 1. Let's try another one. Let's say you were given the whole number 6. Well, first write that whole number as 6 over 1. Then we're simply going to flip it. And that's right, we get 1/6. Let's double check with multiplication. Make my eraser smaller. 6 over 1 times 1 over 6. 6 times 1 is 6. 1 times 6 is also 6. 6 divided by 6 equals 1. Let's try one more. Let's say you were given the mixed number 2 and 1/2. First, change that mixed number to an improper fraction using MAD. Remember, multiply, add denominator. 2 times 2 is 4. 4 plus 1 is 5. And our denominator stays the same at 2. And then the reciprocal of 5/2 would be, that's right, 2/5. Let's double check with multiplication. 5/2 times 2/5. 5 times 2 is 10. 2 times 5 is 10. And 10 divided by 10 equals 1. So we can see that those numbers really are reciprocals of each other. Okay, now that we know what reciprocals are, let's practice a little bit more. Another name for a reciprocal is multiplicative inverse. That's a tongue twister. Multiplicative inverse. What are some words in everyday language that are similar to reciprocal or inverse? Any ideas? Maybe you've heard the word invert before, and this doesn't have to be words from math. It could be from anywhere. Or maybe reciprocate. Okay, those are words that, let me add the E on reciprocate. Words that are similar to multiplicative inverse and reciprocal. Pilots can fly in an inverted position or upside down. How can you use the everyday meaning of invert to help you remember the mathematical meaning of multiplicative inverse or reciprocal? Well, we could say that when a plane flies in an inverted position, what the top and bottom of the plane exchange places. So, in a reciprocal, the numerator and the denominator of a number trade places. Let's write that down. In an inverted plane, the top and bottom of the plane trade places, just like the numerator and denominator. Okay, once you've got that copied down, let's go ahead and move on. Okay, so let's just practice finding some reciprocals to make sure we've really got this. And you can see I've got a picture of flip-flops here to try to help us remember that word refliprical reciprocal. So let's write refliprical one more time just to help us remember. Okay, let's say you were asked to find the reciprocal of 2/3. The reciprocal of 2/3 is 3/2. Let's check that with multiplication. 2/3 times 3/2 equals 6/6, and we know that 6 divided by 6 equals 1. So we know that 2/3 and 3/2 really are reciprocals. Okay, let's try another one. The reciprocal of 1/8 would be, that's right, 8/1, or that simplifies to 8. Okay? Another reciprocal of 5. Remember, write that 5 as 5/1, and the reciprocal of 5/1 is 1/5. Very good. Okay, now that we've done some work with reciprocals, it's time to get into dividing fractions. There are two different ways to divide whole numbers by fractions. We'll first learn how to divide fractions using a model, and then look at dividing fractions using an equation. Let's discuss the steps for each. Method 1, using a model, and this is where we're going to use our virtual manipulatives. When we use a model, the very first step is to model the first number in the division sentence. And remember, that first number is called the dividend. Okay? After we've modeled the first number in the division problem, we then divide the dividend into groups according to the divisor. Okay, and that's the steps for using a model to divide whole numbers by fractions. Now let's talk about the steps when you use an equation. When you use an equation, the very first step is to write all whole numbers over 1. The second step is to multiply the first number by the second number's reciprocal. So that's where that reciprocal is going to come into play. Okay, so yes, when we divide fractions, we're actually going to be changing them to multiplication problems to help us solve them. Okay, so let's go ahead and try an example together now. Our first example is 3 divided by 1/4. So we're first going to try this using a model. So go ahead now and pull up your virtual manipulatives. I'm going to pull up mine. Okay. And the first thing we're going to do is just go ahead and write our division problem, which remember was 3. 3 divided by, let me just double check, 3 divided by 1/4. Hold on a sec here. Okay, so let's write that down. 3 divided by 1/4. Remember, step 1 when using a model is to model our first number, or in other words, our dividend, which is 3. So I'm going to select the fraction tab and pull out 3 of the 1s to model my 3. Okay, that's step 1. Now we need to put these into groups of 1/4. So I'm going to select my 1/4 and just line those up with all of my 1s. Okay, make sure you're lining them up correctly. You should have 4 1/4 pieces for each whole number 1. Remember, the fraction 1/4 means you need 4 of them, okay, to make a whole. Okay, so I've got all my 1/4 groups. Now we're putting them into groups of 1 because our numerator is 1. Okay, so I'm just going to be circling each 1/4 piece. And you can see here that we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces. So 3/4 divided by 1/4 is 12. Go ahead and take a screenshot of that. And then we're going to drop that into GoodNotes. Okay, make it a little bit bigger so we can see it. And that's how we divide with a model. Now let's divide 3 divided by 1/4 using an equation. So again, we're going to start with 3 divided by 1/4. Remember, our first step when we have an equation is to write our whole number over 1. So I'm going to rewrite this as 3/1 divided by 1/4. Okay? Next step is to multiply our first number times the reciprocal of the second number. So I'm going to change my division sign to multiplication, and my 1/4 becomes the reciprocal, 4/1. Now I simply multiply straight across, as you already learned how to do with multiplying fractions. 3 times 4 is 12, and 1 times 1 is 1. So we get a quotient of 12/1, but we're going to go ahead and simplify that to 12, since we know that 12 divided by 1 equals 12. So you can see in both examples here that we have 12 as our final answer. So let's go ahead and write that up at the top here. 3 divided by 1/4 equals 12. And that's our first dividing fractions example. Let's go ahead and try another one. Our next example is 2 divided by 1/3. Let's go ahead and pull up our virtual manipulatives and we'll try it that way first. So 2 divided by 1/3. So I'm going to write down 2 divided by 1/3. Remember, first step is to model your dividend or your first number. So we're going to select the fraction tab and pull out 2 whole number ones to model the 2. Now we're going to be grouping those ones into 1/3 groups. So go ahead and select your 1/3 pieces. And remember, 1/3 means that you need 3 pieces to make a whole. Okay? So each whole number 1 should have 3 1/3 pieces. Now, since our numerator is 1, okay, I'm going to circle these in groups of 1. Okay, so each 1/3 piece is its own group. Now I'm going to count how many groups I have. 1, 2, 3, 4, 5, 6. So we can say that 2 divided by 1/3 equals 6. Go ahead and take a picture, screenshot, drop that into GoodNotes. Make it a little bit bigger so we can see it. Okay. And now let's try that same division problem using an equation. So I'm going to start with 2 divided by 1/3. And once again, remember the first step is to write that whole number over 1. So I'm going to rewrite this as 2 divided by 1/3. Okay? Now, remember, we're going to take our first fraction and multiply it times the reciprocal of our second fraction. So again, our division problem becomes multiplication, and you find the reciprocal of the second fraction. So 1/3 becomes 3 over 1. Now simply multiply straight across. 2 times 3 is 6, and 1 times 1 is 1. So we get a quotient of 6 over 1, but you know we're going to simplify that to 6 because 6 divided by 1 is 6. Again, you can see we get the same final answer no matter which way we do it. Go ahead and write 6 as your final answer up at the top for our quotient. Okay, let's try another one. Our next problem is 7 divided by 2/3. So go ahead and pull up your virtual manipulatives app. Again, we're doing 7 divided by 2/3. Let's write that down. 7 divided by 2/3. Okay, so remember, start by modeling the 7. So I'm going to pull out 7 of the 1 whole pieces. Make sure we've got enough space. 2, 3, 4, 5. Move this over. 5, 6, 7. Okay. Okay, next step. We're dividing that by 2/3. So we're going to use our 1/3 pieces. Okay, and then the difference will be when we go to group these, we're going to put 2 1/3 pieces together since we're dividing this by 2/3, not 1/3. Okay, but for right now, just go ahead and model those 1/3 pieces. Remember that you should have 3 pieces for each whole. Since 1/3 means you would need 3 of these to make a whole. Okay. Mix up another side here. Don't want that 1/2 piece. I'm just actually going to go ahead and put these right over the ones. Just because we're running out of space. Feel free to do the same if you're running out of space. Okay, so now when we do our groups, we have to put 2 1/3 pieces together in each group. Okay, so that's one group. There's another group of 2, another group of 2, another group of 2, another group of 2, another group of 2. Another group of 2, another group of 2, another group of 2. Another group of 2. Okay, and you can see also that we've got 1/3 piece by itself, so hold on to that for 1 sec. Let's count how many we've got so far. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we've got 1/3 left over. So we're going to go ahead Okay, so this is where it gets a little complicated. Okay, we've got 10 whole groups. Write my answer over here, 10 whole groups. Okay, and then this 1/3 piece, we're not writing 10 and 1/3. We're actually going to write 10 and 1/2, and here's why. That group of 2/3, okay? We don't have a whole group of 2/3, we only have half of that, okay? 1/3 is 1/2 of 2/3. Okay, I know it's a little complicated, but it should make more sense with time, so go ahead and take a picture. And then let's drop that into GoodNotes. Okay, and then let's also do this using a model. So we're going to do 7 divided by 2/3. Again, start by writing that 7 as 7/1 divided by 2/3. Then we're going to multiply our first number, 7/1, times the second number's reciprocal. So division becomes multiplication, and 2/3 becomes 3/2. Multiply straight across. 7 times 3 is 21. 1 times 2 is 2. So we get 21/2. But we're going to go ahead and simplify that. Okay, and 21/2. Remember to change an improper fraction to a mixed number. You're going to do 21 divided by 2. 2 goes into 2 one whole time. 2 minus 2 is 0. Bring down the 1. 2 goes into 1 0 times, which means we have a remainder of 1. So that will be written as 10 and 1/2. So we get a final quotient of 10 and 1/2, which remember is the same as what we got in our original problem. Okay, so go ahead and write that quotient up at the top. 10 and 1/2. Okay, let's try another one. 6 divided by 1/3. So let's go ahead and try that with the virtual manipulatives first. So pull that up. Okay, so I'm going to start by writing 6 divided by 1/3. And again, start by modeling your 6. 6. 2 of these over here, so we have enough space. Okay, we're dividing this by 1/3, so I'm going to drag out my 1/3 pieces and split each group one whole into 6 pieces, or excuse me, into 1/3 pieces. So my 6 wholes are split into 1/3 pieces. Remember, you should have 3 1/3 pieces underneath each whole, because that third means you need 3 of them to make a whole. Okay. Since we're dividing by 1/3, each third is its own group, so go ahead and circle your groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 total groups. So 6 divided by 1/3 is 18. Go ahead and take a picture. Let's drop that into GoodNotes. Okay, so you'll notice that when we divide by fractions, we actually end up with a bigger answer, and that's okay. Okay, let's go ahead and try 6 divided by 1/3 with our equation. Remember, begin by writing that 6 as 6/1. Then we're going to multiply times the second number's reciprocal. So we're going to do 6 over 1 times 3 over 1. Multiply straight across. 6 times 3 is 18. 1 times 1 is 1. But we know we're going to simplify that 18 over 1 to 18 because 18 divided by 1 equals 18. And you can see from both methods we get the same final answer of 18. Okay? Let's try another one. Now we've got 5 divided by 2/3. So again, let's start by using a model. Pull up your virtual manipulatives. Okay, I'm going to start by writing 5 divided by 2/3. And again, start by modeling the number 5. 2, 3, 4, 5. I'm just going to space these out a little so we've got room. Okay, we're dividing it by 2/3, so we're going to use the third pieces, and then we'll be putting them into groups of 2. Remember, you should have 3 1/3 pieces underneath each one. Okay, and again, now we're going to group them into groups of 2 because our numerator is telling us to put those in groups of 2. Okay, so group of 2, 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 another group of 2. Notice how we do have that 1/3 by itself. We'll talk about that in a moment. But right now, how many whole groups do we have? 1, 2, 3, 4, 5, 6, 7. Okay, remember that 1/3 piece is 1/2 of a group. See how it's 1/2 of a group here? So we're going to say 7 and 1/2 is our answer. Okay, go ahead and take a picture. Drop that into GoodNotes. Okay, now let's try it using an equation. So again, start by writing 5 divided by 2/3. Step 1 is to take that 5 and write it over 1 since it's a whole number. Okay? Then remember we're going to multiply our first number times the second number's reciprocal. So 5 over 1 times 3 over 2. Multiply straight across. 5 times 3 is 15 and 1 times 2 is 2. So we've got a quotient of 15/2. But remember we're going to change it to a mixed number. So to do that, do 15 divided by 2. 2 does not go into 1, but 2 goes into 15 a total of 7 times. 15 minus 14 is 1. And we're going to write that remainder as 7 and 1/2. So you'll notice that we get the same quotient in both of our methods. So we're going to go ahead and write our final quotient up at the top of 7 and 1/2. Alright, let's try another one. Our next one is going to be 4 divided by 3/4. So again, let's pull up our virtual manipulatives. And we're going to write down 4 divided by 3/4. Again, start by modeling that 4, our dividend. Okay, we're going to put them into groups according to the divisor. So we're dividing it by 3/4, so we're going to use our 1/4 pieces, and then we'll be putting them into groups of 3. Make sure you have 4 1/4 pieces underneath each whole number 1. Remember that 4 means you're cutting that whole number up into 4 same size pieces. Okay, and again, remember that numerator is telling us to put them into groups of 3. So circle 3 at a time. So we've got a group of 3, a group of 3, a group of 3, a group of 3. Alright, and then I'm going to move these 3 together to make another group of 3. Okay, and then you see we've got that 1/4 left over. That 1/4, if you look at a group, is 1/3 of that group, okay? Because there's 3 pieces in each group. We've got one of the pieces. So that 1/4 represents 1/3 of a group, okay? Up so you can see. So we can say that 4 divided by 3/4 is 5 and 1/3, because we've got 5 whole groups and 1/3 of another group. Go ahead and take a picture of that. Drop that into GoodNotes. And then let's try it using an equation. So again, we start with 4 divided by 3/4. We're going to take that whole number 4 and write it over 1. So we've got 4 divided by 3/4. Okay. We're going to take our first number and multiply it times the reciprocal of our second number. So 3/4 becomes 4/3. Go ahead and multiply straight across. 4 times 4 is 16. 1 times 3 is 3. So we get a quotient of 16/3. But we're going to change that to a mixed number. So remember, do 16 divided by 3. 3 does not go into 1. 3 goes into 16, a total of 5 times. 5 times 3 is 15. 16 minus 15 is 1. So we get 5 and 1/3 as our final quotient, which is the same as what we got in our modeling step. So we can write our final quotient up here as 5 and 1/3. All right, let's try another one. Okay, a couple word problems. At summer camp, the duration of a field hockey game is 3/4 of an hour. The camp counselors have set aside 6 hours for field hockey games. How many games can be played? So we need to do 6 divided by 3/4. Okay, well, let's start with our model. So pull up your virtual manipulatives. Okay, I'm going to go ahead and write 6 divided by 3/4. Okay, we're going to start by modeling our 6. Go over here. Okay, and we're dividing it by 3/4, so we're going to use our 1/4 pieces. Remember that you should have 4 pieces for each whole number 1. That 4 means you need 4 pieces to make a whole. Okay, and now our numerator is telling us to put them into groups of 3. Groups of 3. So group of 3, group of 3, group of 3. Oop. This is another group of 3. Okay. So let's see, we have nothing left over, so let's count our total number of groups. 1, 2, 3, 4, 5, 6, 7, 8. So we can say that 6 divided by 3/4 equals 8, or in other words, they have time to play 8 field hockey games. Go ahead and take a picture. Let's drop it into GoodNotes. Okay, and now let's try the same problem using an equation. So we're going to again start with 6 divided by 3/4. Okay, start by writing that 6 is 6 over 1. Then we're going to rewrite this as a multiplication problem, multiplying the first number times the second number's reciprocal. 3/4 becomes 4/3. Okay, now notice with this one, we have some things we can cancel. That's right, we can divide 6 and 3 by 3, so you can still use the canceling you learned from multiplying fractions here. 6 divided by 3 equals 2, and 3 divided by 3 equals 1. Now multiply your new numbers together. 2 times 4 is 8, 1 times 1 is 1. So we get a quotient of 8 over 1, but we know we're going to simplify that to 8. Okay, because 8 divided by 1 is 8. Notice we get the same final answer both times, so we can say 8 games can be played. All right. Got just one more to try. A neighborhood development that is 4 acres is to be divided into 2/3 acre lots. How many lots can be created? So we need to do 4 divided by 2/3. Okay, so let's try this first by using a model. Pull up your virtual manipulatives. And I'm going to go ahead and write 4 divided by 2/3. Again, start by modeling the number 4. And then we're going to cut this up into 1/3 pieces. Remember, you should have 3 pieces for each 1/3. Okay, our numerator is telling us to put these into groups of 2. Let's go ahead and do that. Count the total number of groups you have, 1, 2, 3, 4, 5, 6. So we can say that 4 divided by 2/3 equals 6. Go ahead and take your picture, drop that into GoodNotes. Okay, now let's try the same thing using an equation. So write 4 divided by 2/3. Okay, we're going to write that whole number 4 as 4 over 1. Next step, multiply by the second number's reciprocal. So 4 over 1 times 3 over 2. Hopefully you can see there's some things you can cancel here. 4 and 2 are both divisible by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. 2 times 3 is 6. 1 times 1 is 1. So we get a quotient of 6 over 1. Again, we're going to simplify that to 6 because 6 divided by 1 equals 6. Again, you can see we get the same quotient no matter what method we choose. So we can say that a total of 6 lots can be created. Okay, so that concludes our notes on dividing whole numbers by fractions. Make sure you do the note check before moving on.